was there for minutes, for like at least half a minute. So that's nothing. Usually now it starts. I don't know whether we have to switch it. Does it automatically switch?
So there are a number of techniques people use in lightning talks. I normally use the one of the timer and starting to applaud, but Mark Smith, who did them at EuroPython, had this other technique where he would sort of stand over here during the lightning talk, and as the time got close to 5 minutes, he'd slowly get closer and closer to the speaker till it was very friendly indeed, and that was usually quite effective. He also, Mark Smith is like me from Edinburgh, and he did it in full kilt, and he also had a technique of sitting in the front row. And those of you who know the traditional way of wearing kilts in Scotland mean that sometimes some of the lightning speakers got to know Mark slightly better than they might have liked to do. Are we making any progress here with the lightning talks? No. Okay.
So, no lightning talk for you.
I think, Alex, could you really not do it without slides?
No.
No. Okay. In which case, I think we're going to have to move on.
Maybe I can lend his laptop and
Okay, let's see if we can do the second one. So the second lightning talk. I can't read. Reinforcement learning with easy agents. New laptop. We're going to try a new laptop.
let's see. Maybe
This is very straight. It's almost, I mean, I'm from Scotland, and some of you will know we're having a few issues in the UK at the moment with complete maniacs having taken over. The good news is, I'm supposed to tell jokes, so here's a joke. What do you call a prime minister who has never succeeded in winning a vote in Parliament? Boris. And you see, yesterday that wasn't very funny because he'd only had one vote, but now he's had 4 votes and he still hasn't won one. Oh, now you see, this looks quite hopeful. This looks very hopeful.
Oh, no worries.
So, excellent. So you should introduce yourself, and as soon as you've introduced yourself, I'll start the timer.
Perfect. So I'm Oliver. I'm showing, DJ Korthose. I'm showing something about reinforcement learning, and I'm also making some sort of advertisement for easy agents. So this is the bear. You see the bear in the middle? And the task of the bear is to find all the honey pots in the picture. But the bear is also lazy. That's the nature of the bear. And he doesn't walk too far, doesn't want to walk too far. He doesn't like to swim. And the connections, the blue ones are lakes. The brown ones are mountains, I guess. The dark green ones are woods, and the light green ones are grasses. So he prefers certain paths, and others he doesn't like. So, and the idea is to find the minimal possible path to get all the honey. So how do you do this? So as it turns out, this can be solved doing reinforcement learning. Anyone ever heard of reinforcement learning? All of you. Holy goodness. Okay. So obviously, maybe you don't have a bear and you don't solve like collecting honey, but it might be operations research. This is actually the traveling salesman problem, more or less. And it turns out it's possible to solve it using reinforcement learning. How does it work? So you see a typical picture, which has always been confusing to me. So you consider there's 2 modes of a reinforcement learning agent. So the play mode, where the agent knows what to do, and that agent would be the bear. So our agent bear on that right side there, and the bear does things to his environment. In our case, the bear goes somewhere, chooses a certain path. And then the environment would be simulated, and in that simulation, going somewhere would cause a certain response. Getting a reward, sweet honey, and then new observations, how does the world look like now? So, and then in learning mode, there's a new element, the element at the bottom there. And that is the thing that takes these measurements and makes adjustments to the strategy of the bear. So the bear probably doesn't have a physical device attached to his head, but he simulates this world, and then he tweaks his strategy. And the what he tries to do is get the highest reward. And that's actually reinforcement learning. And this is our library that my friend Christian and I built. It's a very high-level library for reinforcement learning that lets you concentrate on defining your problem. And once you've done that, you choose a certain learning strategy. Well, you just choose this one, actually, and then you see over time how the bear learns. And the stuff on the right here is the reward. And if it goes up, good. And the path that he takes is the thing in the middle. If it goes down, also good. Let's see. So the bear learned stuff. Let's see if I can play that, hopefully. That's what the bear actually does in this specific scenario. And you see he walks around, he swims through a lake. Unfortunately, he does have to do it. But now, if he can, he avoids the lake and takes the longer path to get back home. And this is something you can teach a system like this without having any data. So you produce the data while you're training. Final slide. The thing that we build is just for practitioners. So you define your environment. You just fire this stuff off. And under the hood, it uses TF agents, TensorFlow agents, OpenAI stuff, and allows you to use policy gradient strategies, PPO, which is pretty advanced stuff, and deep Q networks. So if you want to give it a try, we have the bear example over there. And if you want to talk about reinforcement learning or machine learning or TensorFlow, talk to me later. And then that's it already. Thank you.
Fantastic, ahead of schedule. Okay, Alex is going to try again. No, don't unplug the laptop. You're disrespecting everything.
I'm so sorry. No, try it. But
Alex is going to try again.
Yeah, the USB.
Are you cool with that?
Yeah,
I'm cool.
it's fresh. It's a fresh one.
We'll have Alex trying between every pair of lightning talks.
Yeah.
So next up, we should have profiling Python and C. Do we have someone here for that?
Okay.
Excellent, that's next.
How can I leave this actually?
And after that, how can you leave? Well,
Yeah, that's.
and after that, we have Intel Dal for Pi. It's you again? Oh no, it's you. It's a different you. That's good. Okay.
It's on the USB stick. Maybe you can open it a little bit faster with the computer. Sorry.
So while we're going, okay, the laptop still seems to be working. So while we're going, here's another joke for you. What do you call a prime minister whose brother resigns from his government within weeks of his starting?
That's okay. Yeah, just like push to full screen.
Yes, that would be Boris as well. Joe Johnson's
Whereabouts
man.
is it?
Yeah, full screen. Yeah, do it.
I can't see
Okay.
full screen. There we go.
Okay, I think we're going. So
Yeah, okay, I can live with that. So I
okay.
can probably just move it now with the. Oh, okay, that's going. Okay, probably you have heard about PyCon as a German Python conference. Probably you also heard about PyData Berlin. And it's like another great conference. And just like what we did this year is actually to join both conferences and go to Berlin on October, which is great. I think my main message here, and you will see that in a minute, and if you have a good eye, you already see on the left side here. I think the main message here I want to get across is it was a very good idea to join both conferences. It was very received from both communities to bring Python communities back together again. So if you're like super excited to go there, I'm very sorry. We are sold out. We have 1,100 people in Berlin on this conference, more than, and yeah. So if you want to still come, there's a wait list. You can sign up. But my main message here is like it was a really great experience bringing the both communities together, align on the mission, and make a great conference in Berlin. And just like, sorry, we're sold out. There's a waiting list. You can take your chances there, but there's always a next year. Thank you.
Thank you, Alex. Okay, so next up we have whatever I just said. Oh yeah, we have reinforcement learning. Don't we? Oh no, we had that. No, we don't. We have profiling Python and C. That's much better. It's not much better. I don't mean it's much better. I mean, it's much better that we have a new talk than that we repeat the old talk. Come on. Oh, people. So, this laptop's going to work first time. I'm entirely confident. Did you test it?
No.
Ah. Always be testing it, it says on my back. That was your task during coffee. Yeah, Intel DAL 4Pi, I think.
Let's hopefully show
Okay,
the picture.
fantastic. So, introduce yourself. I'll give you this.
Okay, so my name is Vasily Litvinov. I am a software engineer from Intel. And this lightning talk is about, well, the main idea would be in a, not next, but next to next slide. But this talk is about profiling Python. So first there's some legal thing. I just go on. And now this is the core idea of my talk. So when you care about performance, or when you wonder what's going on in your application, just don't guess. There are tools. There are a lot of tools. You don't necessarily have to use our tools. Well, I would like you to, obviously, because I do them, but I'm not forcing you. So, well, you know, like a small cell story, why would you need it? Well, obviously because it powers a lot of software, like an HPC stuff, all of you know. And sometimes it doesn't scale well enough. So you go profiling like CPU or lux analysis, or where did your memory go suddenly. And not all the profilers are there which are like equal to each other. There are in a few groups. You can group them by certain things. And the most probably widely known one is the cprofile. It's event-based. Basically, it tracks when you enter and leave a function. And it can give you the granularity of you are seeing that this function is taking too much time, or this function is taking like a little of time, but you won't know what's going on inside the function. Then there are instrumentation-based profilers, like line profiler, which would allow you to see exactly what line is being slow in your function. And there are statistical ones which take samples, like every 10 milliseconds we look at what's the state of your program is, and we record it, and then we think that the function which is the slowest one would float up, and would be a hotspot. Now, there are some features I just mentioned. I'll go forward. You can all look in the recording. And easiest one is the CPU usage profiling, and there are literally a lot of tools. They're all here. Again, the recording should be to the rescue. I won't be reading those out loud, or everybody would be asleep. Of those things, I would like to highlight the VMProf, as it's a statistical one, and it gives you the line level information. I think should be on Windows, Linux, and Mac OS, even if Windows support is somewhat flaky. Then there's recent additions, or not so, of PyFlame and PySpy. And the last two ones, a small disclaimer, I made a lot of work for them to happen. They are all statistical ones here, so they influence not so much. And some screenshots. So the idea is that we take the very well-known problem of joining strings, concatenating strings via += or via join. Like, I won't stop on this code. So here's what cprofile looks like, if you're not familiar with. Here's what it looks like in a PyCharm, much nicer. Here's the line profiler. So you see individual lines, but the overhead is, so it's slowing your application easily dozens of times down. Now this is what Visual Studio used to look. I'm not sure how much it looks like now, but it should be somewhat similar. This is what one of the collectors I'm talking about, the PySemProf. It's a open source version, so it's an Apache 2.0. You can find it on GitHub. And this is what vTune looks like. So you see the call stack to the right, and you see times of being spent in this function. So, and some results, what I can tell to the scientific community is that we used this tooling, and we sped up FreeCSV and pandas on certain benchmarks from, like, you read the figures here. And yeah, and extra points for those who are interested in Numba. Numba can be seen in vTune. I don't think any other profiler I mentioned supports that, so it might be of interest for you, like through the GTIT code. Again, you shouldn't guess. I listed like a dozen of tools. Just pick one and use. So the closing slide, Vitun is free to use for you to sign up. It's closed source, but it measures more than Python. Python Prof is fully open source, as I say here. You can take and use one. Or just pick any of the other tools and be at ease with using them. Just don't guess. Don't guess.
Thank you so much. That's brilliant. And so next we have PyDAL, is it? Something like PyDAL. I really should take this phone with me. It's about DAL. Excellent. And then after that we have N-body performance. Do we have the lightning speaker for N-body performance? Yep. Okay, fantastic. Have you tested your laptop?
No, I didn't.
Okay.
I tried to do it.
So the message didn't really get out. It's going to be fine. We have complete confidence. It's not one of those Mac things. It's a ThinkPad, so it's bound to work.
Okay.
We believe.
And
And it's nearly there.
looks like it works.
There you go. So introduce yourself. Give you 5 minutes on the time.
Hello, everyone. Nice to meet you. It's really pleasant to be on this conference. So right now, wait a moment. I'm Alexander Makarev. I'm from Intel, and I am working with Data Analytics Acceleration Library. So right now you understand two simple things. This is one more software engineer from Intel, and he takes his slides from a previous reporter. And the both things are true. Yeah. So, disclaimer again. And I did not prepare a presentation, really. So let me just explain what I want to say to you. I had a lot of conversation with a lot of interesting people here, and when we discuss what kind of job we have and what we do for community, for Python, and when I said that we at Intel develop machine learning library, most of all says, oh, we don't know about it. We have never seen it. So today I want just to show to you something like light promo. Okay, so for some reason screen is not available again. I missed it. Excuse me, can you help me?
It's like a practical joke on speakers, isn't it?
Excuse me, may I ask a quick question?
Yes, of course.
Okay, when it comes back, can you put on the entire slide again?
Okay. This one.
Okay, all right.
Okay.
There's the snake spider, right? Python plus Intel is the snake. Is it something like that, right? So the light in the tail of the snake, is this a bug?
Possibly. Possibly. We need to investigate it. Okay, so I will just like to show to you that if you will combine 3 favorite words, such as Python, GitHub, and maybe the last one is not favorite word for everyone, but Intel in the Google, you can get on the first line our organization, Intel Python. So we create open source projects. Yeah. I'm not sure about internet connection, that's why I just opened pages before this presentation. So you wait a moment. You can see that one of the projects have a name DalphaPy. This is Python API for one of C++ Intel's library, which name is Data Analytics Acceleration Library. So, and here available several links in the top of the README. So, first of all, it is documentation, and the last one is about Intel's DAL. I can say about, I cannot miss them because they have own well-documented documented web site. They have good documentation with description of algorithms, detailed description of algorithms. This is an example for Kamins, I believe. Yeah. So what we are doing? This is the documentation for DalphaPy and example of the code. You can see. So I like scikit-learn. It's wonderful. It's amazing. I believe that you like scikit-learn too. And our DalphaPy is scikit-learn-like. You can see that it can be easier to run, for example, linear regression in this code. I heard several questions about sparse data. So for this moment we're working with NumPy, Pandas and SciPy sparse matrices. And we implement zero copy, so we don't spend time on providing such data to algorithms. I see the timer, yeah. So this is an example that we have already available a lot of machine learning algorithms. So maybe you can solve some your problems, your issues with our software. And we have scikit-learn compatibility. And my time is up. Thank you.
Thank you so much, it's working. So we have N-body performance next, and then we will have analyzing Formula One points systems. Have you checked your laptop? Oh, yeah. We have a laptop, we have somebody who might work. Yes, excellent. Fantastic. So while we're setting up, continuing the enormously positive Brexit news, turns out that about 25% of Britons are in favour of a no-deal Brexit. And what do you think about 25% of the Britons who are in favour of a no-deal Brexit think that it means absolutely nothing will change in Britain? They're fed up with it, they just want it to go away, so they want no deal. And this is not funny. This is extremely good. It looks like it's going to work. Excellent. So introduce yourself.
My name is Sebastian Ernst. Let's say lately I've been doing a lot of data science work, consulting as a... Sorry? Louder. Now better? Okay, I have to be closer. My name is Sebastian Ernst. Lately I've been doing a lot of data science consulting work, sometimes teaching, sometimes building software and analyzing data. And one of the things that I came across was, like most of you guys, how to make my code faster. Now, I stumbled across Julia, and what the Julia people say is that Python has a two-language problem, because basically at some point you need a second language to make stuff work, or you need a compiler or something like that, or a transpiler. What they see as a disadvantage I call the multi-language strength of Python, and the fun part is now, well, you have a certain problem, how do you approach it? Which of the many, many, many tools do you use? So what I find myself doing really is, for different problems, depending on what I do, I implement benchmarks, meaning that I first implement a problem kind of in a slow way, and then I try to make it faster using different ways. One of my toy examples really, and I use this as the basis actually for customer projects, is, well, this thing. It's an N-body simulation, and what you can kind of see on the x-axis is actually the number of bodies, and the y-axis is kind of the computation time per iteration. So this is not meant to be physics, it's not meant to be accurate, it's not meant to be perfect, it's simply meant to analyze performance using different tools. if you type the stuff up there into your browser or use the QR code in the bottom right, you get to the website, the GitHub repo, you can check this stuff out. And you can even kind of go into the plot and see the different solutions. Now, what I want to talk about here really is it's hard to figure this out, and what I observe is you see basically changes between different versions of the different tools. Like Number has improved lately a lot, so you see improvements here in the Number part. There are two solutions I call NB1 and NB2, for instance, here different implementations using Number. Other tools like NumExpression also have seen certain improvements. So at the end of the day, I write those benchmarks, I take them to different machines, and I test them on different machines, and they have different characteristics. One idea that I heard on this conference was that why not use a generic framework? And there was actually a nice presentation yesterday about a more generic framework that can use Number and different other stuff underneath. And one question was, what about micro benchmarks? Like you have your Python code and you want to accelerate it, and maybe there's a framework which can use different tools and measure what is best and then use it on a certain machine or something like that. So this is something I would like to encourage, and if someone's interested in talking about this, I'm here to talk. The other thing I would like to encourage, I'm really collecting those experiments. The ones on the right, they have certain names, like the stuff with C in front is usually C, and then there's CY, it's Cython, NP is different NumPy stuff, different ways of approaching this with NumPy. What I want to encourage you is actually contributing experiments like that. It's all GPL licensed, so you can basically mess around with the code and basically put in proof of concept. One interesting aspect is kind of implementation complexity, because a lot of those tools have a somewhat learning curve when you want to deploy your code. How do you write setup PI files and all this kind of stuff? And again, this is kind of part of my kind of personal analysis, like how much work you actually need to put in, how complicated does your code become, and then kind of what is the benefit. You see a large spread across the different solutions, and certain things I can explain, certain other things I cannot explain. Like again, in the Number case, I guess I discussed it with a Number developer. If there's anybody out there who understands certain effects in NumPy, where it's slow in certain cases and fast in other cases, I'm also happy to talk about that. So that kind of concludes, I guess, this lightning talk. N-body simulations, experiments, performance, and the multi-language strength of Python, and the many, many possibilities of making your code faster. Thank you.
Fantastic, thank you very much. So next we have analyzing Formula One point systems, and then we will have building data object for multi-physics simulation.
Hello.
How's your laptop? Have you tested it?
I actually did test
You
it.
did test it, that's what I like to hear. That's music to my badge.
Yeah, doesn't work.
We'll have to hold our breath. It's coming. It's trying really hard. Pulling it out, that's a bad idea.
So, my name is Leevi, and I'm a huge Formula One fan. So my history in the field is that I started watching Formula One with my father when I was a kid, and I really started getting interested when Mika Häkkinen, Finnish driver, won 2 championships in a row. But unfortunately, the sport is really boring nowadays, so I have this data set that I've been toying with to make the sport more fun again. So we don't want to punish the teams for being too good or reward them from being too bad, and we don't want to increase randomness in the results by adding artificial rain or something like that. So the way we have left is different point scoring systems. So the requirements, it has to be fair, and it's accepted that the winner should get more points than the gap between the drivers should be bigger when the drivers are better. So the gap should be smaller, or at least the same. And the goals for optimizing the point system, we want to make a single race more entertaining. Usually that means we want more overtakes, and we want to make the championship race more interesting. So we want to keep the championship open as long as possible. So yeah, let's design a bunch of point systems. Here we use pandas and NumPy, and it's very ugly. And the other point of this talk is to show you how a non-professional uses these tools. So here's the point systems, here's the modern points, and here's the second one is the way we get all drivers get the point, at least 1 point. And then my favorite is the win count. We just count the wins, and who wins more races wins the championship. But yeah, then we normalize them, because otherwise it would be, they can't be compared. So now the maximum points are 1 in every. And now we calculate the weighted average reward for the overtake, because we want to know how much the drivers get from the overtake. Something like that. So, yeah. And then we also count the drivers who are interested in making an overtake. So here we do that, and here we have the results. With the best, and the third column says that which it implies more action in the track. It's my own metric, and it's probably not really good, but I just made it up on the fly because I was in a hurry. So the system where everyone gets at least 1 point is the best. It inspires more overtakes. So now let's take a look at the championship data. I have results from 1950 to 1980. I found it on Reddit, and it can be found on Google too. So here I use the pandas merge, which is about the hardest thing I can do in pandas. So, yeah. And what we see here is the results, and we have added our custom point systems there. And as you can see, the one who is in second in one race doesn't get the same amount of points as the winner. So it probably works. And now we go through the results by year. And yeah. So the conclusion was that we need to give everybody a point.
Yeah. So did Mika Hakkinen win every year under your system?
No,
Oh,
unfortunately.
there you go. What about Kimi?
He actually lost one championship. But
Oh, well, there you go. So next, thank you very much. Next, we have building data object for multi-physics simulation. We have that. And coming up after that will be distribute tasks over a network. We have... Yes? Fantastic. Hello.
Hello.
Have you tested your laptop?
No,
No?
not yet.
Okay. It's going to work first time. I have a very good feeling about this. It's not a Mac. That's the first part of the good feeling. Definitely not a USB-C Mac. Probably even has a keyboard that works. There you go. Introduce yourself and you'll get 5 minutes.
So, hello everybody. So I'm Émile de Villers, and I will talk about building a data object for multi-physics computation and post-processing. So I'm a research and development engineer at EOMIS, and in EOMIS we mainly do consulting and training to solve noise and vibrations issues in electrical machines, and so for this we do simulation. So we have developed our own software, Manatee in MATLAB code, and we have also launched last year an open Python library, so his name is PyLican, who stands for Python Library for Electrical Engineering Computational Analysis. Please wake up. And the objectives of PyLican are to be a simulation framework for the multi-physics design and optimization of electrical machines and drives. So it involves power electronics, electromagnetics, heat transfer, structural mechanics, acoustics, many physics. So PyLican must be a flexible framework with user-defined workflow and with internal models, and also the capability to interface to external existing software. And PyLican is also supposed to be user-friendly and a unified framework. And in fact, it's the first one and the only one up to now, open object-oriented library of electrical machines. So we are clearly an underrepresented minority in the open source lake. Okay, so for the moment, we have really progressed on developing the electrical machine object. And now we are currently working on building this unified data object, which is suitable for numerical modeling of complex physical systems. So in this system, there are many physical quantities, vibrations, current, electromagnetic fields, temperature, but it's always the same structure in terms of signal. So basically, it's a multi-dimensional signal, and we can use it in the time and space domain or also in the frequency domain. And so now the main question is, how should we create this unified data object to account for this dual domain and only store one because there is a redundancy, and also define different compression levels based on physics to only keep what is interesting in the memory, and also to visualize, compare, and analyze results. So at least multi-dimensional plots, and also be able to make projection in 2D or 3D plots. Okay, so we came up with this idea of data object, which inherits from a time-space object and a frequency object. So in the time-space object, we'll find a multi-dimensional array, and with the time and space basis. We will also have some methods to plot it, to make projections on subspaces, to export the data, to compare different signals, to interpolate, to compute root mean square, etc. So many methods. And on the other side, in the frequency object, so there will also be an array which contains the frequency content, also the frequency basis, and some parameters, for example, to set up the Fourier transform. We'll find also some plots and some interesting feature, for example, extract a specific harmonic or some very powerful tool. And so on top of these two objects, there will be the unified data object, which can be either a time-space object or a frequency object when it was created. And if we simply request the dual object, then it will compute the Fourier transform or the inverse Fourier transform. So with this kind of object, we have a unified formulation, and we have embedded many methods to help visualizing and comparing and analyzing data, multi-physics data. But we still don't know yet if it's really feasible and if it's useful in practice. And so we are also interested to know if you know some existing alternative or what could be possible to fulfill this need. So thank you very much.
Thank you so much. So next up we have... That's okay. You didn't use your full time, so you have credit. Distribute tasks over a network, and then we'll have Dask Job Queue. We have Dask Job Queue. I'm being blinded by the light. We have Dask Job Queue. Yes, we do. Excellent. Fantastic. And it's all working. That's brilliant.
Let's
Introduce yourself, and you'll get 5 minutes.
So, hello everybody. I'm Cédric Marinel, and as the previous speaker, I work for EOMIS. So as he said, in EOMIS we have two softwares to understand and reduce noise and vibrations in electrical machines. So we have Manatee, which is developed in MATLAB, so we will not talk about that right now. And we have our new open source project, which is in Python. And we also would like to solve some problems, which is how can you distribute our computations over the computers of the company or some clusters. And one of the main issue is that the PyLican is coupled with other softwares. So we would like to do parameter strip and optimization. So to do that, we started to develop a module in Python which provide a permanent server with a queue of tasks and also provides gives the ability to connect our computer to give some resources to execute the tasks. So I will talk about that, and this module is split in 3 main objects. So one client, which sends the task to the server and wait for the results. The node, which executes the tasks, and the server, which is the interface between clients and nodes, and which communicate with TCP sockets. So this is an example of architecture that we would like to have. So some clients and many nodes to compute the task. And I would like to focus on one of our issue is what is the best way, the most efficient way to distribute tasks. So this is an example. We have 3 nodes, one with 6 workers, one with 2, and the other with 3. And we assume that tasks cannot be executed on different nodes. So the first task, which is task 1, will automatically be sent to the first node. If a second task arrives, it will wait because there is not enough resources on one node. And the first node will not receive other tasks because if it has all its resources, it would execute the second task. If a third task arrives with 2 workers, we will not send it to the node 1, but we will send it to the second node because we distribute the tasks to the node which has the less workers, and so on. So 4 tasks. And I would like to finish with some questions. So is there any way to improve communications? So TCP socket. What is the best way to store task results? So talk to Emil. Is there a better algorithm to distribute such tasks? And is there any Python package to achieve all these objectives? Thank you.
Thank you. I think we call that hacking the format. Is the next talk also by any chance a PyLican talk? Dask job queue, fantastic. So how's your laptop? Is it?
It's not tested.
It's not tested. Okay.
So
There's not enough testing in this community. Hypothesis is a fantastic library. I'm not sure it would have solved this particular situation.
Just make assumptions first.
Yeah, well, there's a bit too much of that as well. Yeah. So Dask job queue next up will be test Python 3.8. I don't know if anyone can imagine what that might be. Fantastic. You seem to have connectivity. Introduce yourself and I'll give you 5 minutes.
All right, so I'm Eloy Kestel, I work at INRIA. I have a beautiful picture on GitHub that you might have seen. I've been involved in a few projects in the past, 3, 4, 5 years. So scikit-learn and Dask being the latest one. All right, so what's the point of, so first, show of hand, who has heard of Dask in the room? Okay, quite a few people. Who has used Dask already? Okay, a bit less people, and who has the HPC cluster you can access to, for example, if you know stuff like Slurm, SGE, QStat, this kind of stuff. Okay, so there's some overlap, so you might care about what I'm going to say in the next maybe 4 minutes now. Okay, so the point is you have some local, you have some code on your laptop, and you like to, maybe it's not enough, you don't have enough RAM, or maybe it's taking too much time, and you have to you're forced to use a cluster for this. All right, and a better way to say that, if you're Matthew Ruckling, which is the main author of Dask, is to say, okay, transform your supercomputer into an interactive workstation. So I'm going to ask the supercomputer to be nice for this live demo, and I tried to do this last year at Eurosite, but it didn't quite work. So I'm hoping this year it will work better. And basically, I'm going to use the lucky slide of Martin Brundle. So something, hopefully, learn from the pro. That's what they say, right? Something actually this morning keynote made me realize we don't use asterisks enough. So I have the copyright of Martin Brundle there, and please don't sue me if you're in the room or if. Okay, right. You won't, okay. But if the live demo doesn't work, I might call my lawyer and you might be in trouble. So we'll see what happens. Okay. Okay, there you go. So how does it look when you work on a supercomputer? So generally, you go to USSH. So I have this green screen because supercomputer is a bit of the matrix. You're a hacker. You're super happy with your command line, and for example, you can do QStat. So this is my backup job. So hopefully they will stay there. But you could look at the state of the cluster. For example, you could ask, okay, who's using the cluster? Do you have space to kind of run my job? Okay. So here I'm going to talk about an interactive setting. So basically, I want to have a Jupyter notebook on a supercomputer. So I can run JupyterLab like this and run it on the port 999. And in a beautiful word for like scientist or data scientist, whatever you call it, you'll do supercomputer, and then you'll do 9999, and then supercomputer is not found, right? So how do you actually get this notebook? Well, there's a trick that's called SSH tunneling. So this is not quite this, but it looks like it because it should be 999 on both sides. But if you do that, and trust me, it works, then basically what you end up is you can go to localhost 12345 in this case. I'm using the 12345 here, and then you have a beautiful notebook interface the same way you're used to. Okay, so this works to use dash.q. So in this case, it's using SGE. So you instantiate the cluster object. So if you're familiar with Dask, it's very similar to a local cluster object, except this one is going to launch up for you. So once that's done, it's not launching any job. So for example, I can look at my QStat output. It's not launching any job. But when I want to scale to 4 Dask workers, then if you're looking at the output of QStat now, you can see I have some queued job. Trust me, what QW means is like queued worker or something like this. So if now I re-execute the QStat, I have R stuff, and now you can see that the workers are actually connected to the schedulers. And here is actually an interactive widget. You could scale up and down with this interactive widget if you like. Okay, now you create a Dask client. That's how you interact with your cluster. And basically here, there's a web app that's kind of diagnostic thing that you can open. And you can look at the state of your workers. You can see the task. Here I'm using actually a JupyterLab nice extension, so I don't need to do that. But basically, there's a web app behind this extension. So imagine you have some code. So here is this function, that we don't ask you to change, basically. And now how do you actually run this function on a cluster? You interact with the client, and then here you can see that some stuff have been scheduled. The task stream, you can see they're executed. When you do submit, it's actually non-blocking, so you can still print stuff. And if you actually want the result, you call client gather. All this is very you would do exactly the same with Dask local cluster for those who are familiar with this. Okay, so that's one of the API, but you can also, if you're familiar with Panda, you can use Dask data frame. And for example, here, I'm reading CSV on each of the workers. So it's reading CSV, it's doing stuff. Here, I'm calculating the length of the data frame, which is distributed on all the workers. I can compute, it's like flight delay, so I can compute which airport has the most flight delay. And if there are stuff that reading CSV, each time you do the computation is a bit slow. So I'm going to stop.
Thank you so much. I hate doing it to people, but it
Yeah,
it
but
has to
I had
happen.
time to put my last slide, so that's
It
okay.
has to happen. So next we have test Python 3.8, and then we will have plant speed dating. I think I've read that correctly. I don't know whether that's like speed dating for plants or whatever it is. Anyway, how's your laptop?
It's tested.
It's tested. That's what I like to hear. It's tested, so it's going to work. You'll get your 5 minutes after you've introduced yourself.
Perfect.
Excellent. Thank you.
Okay, so my name is Geir Anielle, and I'm here, I guess, to tell you that Christmas comes early this year. And really, there are more important people than me that have been kind of saying this, but Python 3.8 is coming. It will be officially released, the final, on October 21st. And the last beta release is out now. It was released last week. So this is kind of the full schedule thing. But then what's kind of more important is that there is now a call to action. Let's test this beta and make sure that it actually works so that it will be working very well for everybody when we come to October. So Lukas Langa is the release manager for Python 3.8, and he sent out this tweet that we have right here. Have you tried any of the Python 3.8 betas out yet? If not, do it. So then, of course, that's great, but what's kind of an easy way to actually test these things? You could download and install and all that stuff, but actually probably the easiest way is just to use Docker. Most of us are probably already using it for building stuff nicely in production and so on. But the nice team at Docker just keep all the latest betas running in Docker. So if you just do docker run, Python and RC release candidate, you'll get the latest Python, which in this case is the beta 4. And then you can just play with it and make sure that it works. Now, of course, you might want to then actually install some packages and so on. So this just ran Docker, ran Python, sorry, but you may want to then also add the bash so that you can pip install your packages. So for instance, now I can do a pip install some package. Let's do parse, for instance, and it will actually collect this for me. And let's see if there's actually some internet working. There we go, yes, perfect. And then I can make sure that my parse, which is not really mine, but that it actually works and does what it should be doing. So, for instance, let's see. Yeah, it's there at least. So that's one way to do it. You can just add your packages manually, but of course, if you run anything with Docker, you know that it might be even better to use a Docker file for this. So then, in that case, what you would do is something like, okay, let's exit this one. You'll create a Docker file, and then again, you'll just use the Python RC image, and in here you can then run your pip install, for instance. So you'll just do something like, let's see if we're able to do this, yeah. And then I can just do a Docker build for this. So my own Py3.8 thing. And let's see, yeah, actually already cheated a little bit, so this was already done. And then I can just run this one directly. Let's see, what did I end up calling it? Py3.8. So now I have my parse thing here and I can play with it. And let's see, yeah, we can do one more example. Of course, I might have some scripts as well that I want to run. And in this case, probably the easiest way to test your script is just to mount them as local volumes. So then in that case, you can do something like, okay, I do the Docker run, and I want to now test this with my Python RC. And then let's just say that the working directory inside of this is app, and I want to mount the current directory to this app. And then I can run any kind of command in here. So let me actually save this, and let's create a quick hello world. So for instance, in Python 3.8, we're able to do something like this for the f strings. So I can do hello equals. this. And now I can do this one, and I say Python hello Pi. And it then runs it through the Python 3.8. So now I can do this. So yeah, let's just end with the call to action. Try out Python 3.8. Thank you.
Thank you. So next we have plant speed dating. We're going to try really hard to get all of them in. I'm not sure whether we're going to manage. We might run out of time, but we're going to try.
I tested it.
You tested it. That's fantastic. That's the kind of can-do attitude we need. And then it'll be PyMore after that. PyMore is here. Excellent. So I know this is going to work. I have complete confidence. Oh, PowerPoint. See, how could it not work with PowerPoint?
Yeah, I'm sorry about that.
That's okay. If it works, you're going to be in my good books.
All right.
There you go. Nice. Introduce yourself.
All right. Hi, everybody. I am going to talk about plant speed dating, and I know what your mind has gone to. Your dirty minds. It's not what you think. Basically, in plants, there are hybrid plants, and you want to know sometimes how old they are. So that's why speed dating, because you want to do it before your PhD ends. So, some backgrounds. As I said, there are hybrid plants. They usually can have 2 or even more subgenomes, which are original from 2 different species, and when they fuse into a hybrid, they form one genome which has 2 subcomponents. And what's in it for you is that if this happens in the wild, the 2 species are unknown usually, and therefore if the plant is relevant industrially or academically, like in my case, the different properties of the subgenomes could be really important to study. So in my case, I work with Australian tobacco, and it's very little known, and there's very little data, but surprise, a lot of companies are interested because you can produce vaccines and antibodies with it. So that's why my PhD started, and it's about to end, and it is because the available data were really little, but they wanted the most out of that. So what we had was a genome sequence, really fragmented, kind of like hard to use, and as I found out during my whole PhD, just bad. And so, and a lot of gene sets from species related to the tobacco I work with, most of them published by me. And the real question was, how can I can separate the 2 subgenomes of the tobacco I work with without actually having the data to do so? And the answer might be really trivial, really, really trivial. Invent a new method, because the data you have don't work. And so the case study I chose was the only tobacco for which we know a lot. Guess why? I won't tell you. And it's a hybrid, and it's really well known. We know the parents, and we know the date of the hybridization. And so it was the perfect control to see if my script were working, basically. The workflow, and that's where the Python and the coding starts, were that I took all the data I had in the form of phylogenetic trees, which, for those who are not comfortable with the term, are basically direct acyclic graphs, which you can use to find phylogenetic distance, so evolutionary times, basically. And these are the numbers. We're talking about tens of thousands for the 2 species that I used. And what you want to know is the shortest path in the tree, which is basically the closest species related to the one you're studying, which is usually one of the parents. And that also tells you how much time has passed since they diverged, therefore the evolutionary time that you're interested in. And what you do is going into the fabric of the data themselves, which is basically strings, DNA strings, and you find the positions where there are differences. This is where evolution occurred. And if you split that into triplets, which are what the basic biology unit called codon, you can have that looked up into a lookup table, the genetic code, and you can exclude those that are not evolutionarily relevant. So you only keep those that are neutrally evolving, which are those that can tell you something about time. And then, with some magic, you can find ears. And that's all in Python. That's why I'm here, ultimately. And the peaks that you see here are basically the 2 parental species of tobacco that we know of. And the 2 peaks coincide perfectly, and they coincide at the million of years of age, which is also published by the people who made the genome. So the script works, and now I'm using it on my data, and hopefully I will be able to date the plant properly and separate the 2 subgenomes. I'm also doing a little bit of work further. I'm separating the 2 subgenomes using the information of the genes that I dated, not in that sense. And 15% of the genome is still to be assigned, so this is a work in progress. I just wanted to show that I'm doing something actually. And here's a picture of my best friends. I really wanted to show you their faces because I think you don't know them. And that's basically it for me. Thank you. I am Matteo and I work in Vienna.
Thank you. Fantastic. So next we have Pymore. I think there's a chance we're going to make it. We have Pymore and we'll have Texas BBQ next. We have Texas BBQ. We do have Texas BBQ here. Fantastic. How are you doing?
Yeah, good. Let's see.
Did you test it?
No. Apologies.
But you were careful not to make it a USB-C Mac with a dodgy keyboard.
Right.
Yeah. Yeah, I see. Introduce yourself.
Yeah, so hello everybody. My name is Petar and I would like to show you some of the things I'm involved with. So just 3 things. So what is model order reduction in general, the Python package I'm involved with, and funding issues. So kind of the general idea is you have your model which can take some inputs, give you some outputs, but it's difficult to simulate. You want to find a reduced one, so this is basically the picture. You take the same inputs and you get some other outputs, and you would like them to be similar to the original ones. Now, what can the model be? It can be many different things. Then, depending on the type of model you have, there are different methods. So I would recommend you, if you're interested, to check the modelreduction.org, which will direct you to the model reduction wiki, which explains many things. And yeah, so we have a Python package, which does model reduction. And kind of the basic idea here is we have abstract classes for vectors, operators, so what you heard in linear algebra, and so also models. So why do we do this? So one thing is that then we can use NumPy arrays and SciPy sparse matrices to define our models. But what's particularly interesting is that the idea is to integrate PDE solvers. So, for example, Phoenix, DL2, Dune, ngSolve, and many others. To be able to ask the PDE solver to do all the difficult computations because all the stuff is already implemented in C or C++, for example. And we do model reduction in Python. That's the idea. And we are on GitHub, and if you're interested, please check it out. We also have some notebooks and a binder, so you can get an idea what we do. And finally, about funding. So in 2016, there was a DFG. So DFG stands for the German Research Foundation. They had a call for proposals titled Research Software Sustainability, and we applied, and thankfully it was accepted. And this means we can cover 3 positions for 3 years, and I took already one of those positions, and we already filled. And we started this year, so the project will continue for 2 more years. So we hope that this will help with sustainability of the project. So thank you very much.
Thank you. Looking at to Texas BBQ, presumably barbecue. Oh, okay. Yep, we can do that, I think. Next up after that will be the penultimate talk. This is not the Pandas logo. And then we have a very special lightning talk. Topical lightning talk. So suppose you were Prime Minister and you had a majority of -1 because your last MP had just defected to another party. What do you think the logical response would be? How do you think you'd increase your majority? Have an election? No, that's not what he decided to do.
So the only thing is I don't know.
How about sack 21 of your own MPs?
So you're going to have to do that. Well, so I'll just pull this across.
Quite an unusual Prime Minister we've got. Oh.
Right on. All right, that'll do.
Fantastic, perfect.
Wonderful.
Introduce yourself.
Hey, my name's Val. I work at Anaconda. So this is just one last sort of tidbit from the Number project. It's about number integration testing. And so one of the problems we've had in the past with release candidates is that we tend to sort of make release candidates, and then we sort of, we inform people about them. We send, mails out to mailing lists and so on, and then nobody complains, and everyone says, yep, yeah, we don't hear anything, so we assume everything's fine. Then we release our software, and then about a week later, people start complaining that there's bugs in it, and then we need to, produce hotfixes and do all sorts of other stuff in order to, basically fix the code, right? So our solution is that what we're doing is, as we're developing Number, as the master progresses, we continuously test it against the latest releases of popular dependent libraries. So for example, if spam, ham, and eggs would be one of our dependents, then version 042 would always be tested with the latest Number master. And that hopefully averts the need for any kind of hotfixes. The Number solution, yep, it runs on CircleCI. Sorry, a bit laggy here on the laptop. That's good. So it runs on CircleCI, runs nightly. It's a non-bash solution, so it's a Python script that manages to bootstrap a Miniconda environment, which is really convenient. So you can use that as a library, and it reports to Slack. And you can see here that there's 7 jobs in this workflow that have passed. So FastParquet, PyData Sparse, Librosa, Clifford, UMAP, Awkward, and PyGBM. So these are sort of part of the stack that we're currently testing. So that's really useful. What did we smoke out so far? There's been regressions in Number itself. We averted breaking PyGBM with a faulty Number release, which was really cool. And there was some uses in Awkward of sort of undocumented Number APIs that we changed. And then we found out that Awkward uses those, so that was pretty cool too. There's also some breakage caused in dependent libraries by new releases of other libraries they depend on. So currently, I think PyGBM is failing because there's a bug in SciPy. Not entirely sure if they're going to release a hotfix or not. Might also not be SciPy. We're not entirely certain about that one yet, but it's currently failing and we're investigating it. So what did we do then? We generalized it and generalized it to Texas barbecue. So the name comes from a lightning talk given at SciPy this year. Effectively, as you all know, there's like a couple of hard problems in computer science, and naming things is one of them. And at SciPy, there's always a bunch of very clever people sitting in front of the lightning talk speaker called the pun panelists. And they sort of make, crack jokes about, what the people are presenting and, try to be funny and stuff. And, I was talking about smoking out bugs. And so one of the pun panelists suggested to call it barbecue. So lesson learned, don't ever ask the pun panelists to name your package for you. So it's set up for Dask now. So there's some integration that my colleague James Bourbeau from Quantsite, so he set that up for Dask. And we're currently looking for other libraries to adopt it. If you're interested in it, I'll be at the social event tonight. Please feel free to just approach me and ask me about it. Thank you.
Thank you. We're into the home straight. We're running over, but it's going to be worth it, I promise you. This is not the Pandas logo coming up. And then finally, that awful thing that happens in Python where every package ends up starting with py or having py and being some awful fun? We have a talk called Features. I have no idea what it's going to be about. How are we doing? So, you see, I thought it looked like a map, but it's not. It's a slim book. Yes.
Okay, hello everybody. I want to say something that is really, really important. I was looking the other day in this particularly famous data science blog, and what I found in this Pandas article is some strange logo that was looking really familiar to me. And actually, if you're Googling for a little bit of time, you can see this logo popping out in some other blogs, like this one, or this one, for example, which has like a strange tree that it's kind of broken. I don't know why. I even found this version that has it twice in the same place. Then there's another one with a... What?
The bear is not a panda.
Wait a second, don't spoil my talk. You Brazilian mother. So this, I also found this version which has like some sort of pink color that is horrible, and this motherfucker made the bear blind, which makes me super upset. So what the hell is going on here, people? We all know that this is not the Pandas logo, because the Pandas logo is like some sort of matplotlib ugly plot that nobody understands. So if we already know that this is not the Pandas logo, maybe it has to do with this statue over here. Does it look familiar to you? Maybe, if you live in Madrid, it might look very similar than the statue that is living there. And actually, you know what? That the Madrid coat of arms is exactly a bear with a tree. So please stop making Jake van der Plas angry, because he's really irritated by this thing. He already said that in 2016. And also, if you ever have an interview about pandas and they ask you if this is the Pandas logo, then the answer is no.
Okay, brilliant. We've almost made it. Thank you all for your participation and patience and applause. And we are on to Pinchos. This one has to work. There you go.
Perfect. Hello everyone, I am Joy, and first of all I just want to thank the organizers of the conference. This was an awesome 4 days, and I know it's not over yet, there's still the sprints. But okay, so my talk is about this amazing package called Pinchos. So Mark Garcia started in London. He basically, some of the sprints that he did, he basically had an idea that let's make like a Pincho route finder. So essentially it's like a pup crawl, but using Pincho bars. So the first thing that I'm going to do is I'm going to click on this and let it load, and then we'll come back to that. So, okay, so here's the GitHub page. Credit to this, 11 people contributed. I think there was a few more in the actual sprint, and you know, we're standing on top of 25,000 other contributors as well underneath. So that's awesome. So what do? So we scrape the data, we do some optimization because we want to go through a number of Pincho bars in the shortest amount of distance. We want a dashboard, and then we want to continuously integrate it. Okay, so that's the wrong slide. So basically, what do we do to scrape the data? So there's a website called Bilbao Turismo, and they have a very nice layout where you can just go and grab all the Pincho bars. And to do that, we use requests, we use Beautiful Soup, and then once you get the information about each of the Pincho bars, you need to get the longitude and latitude information. So how do you do that? Someone might think, okay, let's use Google. Well, you can't use Google because they now want you to have a billing account. So there is this amazing library called GeoPy, which is a wrapper around other geoencoders. There's like 10 or 12 of them. So you can basically choose which one you want, and there's like 2 free ones where you don't need this. And then we do some optimization. So there is really no optimization in this package right now. Unfortunately, I mean, it would be really, so it's basically the traveling salesman problem, right? You have a start and an end, you have like a complete graph of the distances between each of the points, and you just want to take the shortest route. So I was playing around with it, but like the easiest thing is just to like do some really simple things and then use a greedy algorithm. So we can see how badly that's done later on. And then we have the dashboard. So for the dashboard, currently we're using Folium, Jupyter, Voila, which there's been a talk about, and also Binder. So Binder is just a place where you can host your Jupyter notebook for free, which is where we actually use the link for. And finally, for continuous integration, we use Travis, which means that whenever anyone uploads any kind of code, it will then go and scrape the data in case there is new scraping techniques, and then it will then put it all into a nice place so that this will work. Okay, finally, the live demo. So now let's go here. This is what the app looks like. We don't want to translate this page. So you say, where do you want to start? So first of all, sorry, this is Bilbao. If you guys, I'm sure you guys know about it now. It's taking a bit of time to load. So each of the markers is a different Pincho bar. You can zoom in and find out a bit more information about it. And then the idea is that you basically say, okay, I want to start here, I want to end here, how many bars I want to visit? Well, let's visit 10 bars. And then it will give you a plot like this, where the start one is this one, and then it will basically take you around to however it needs to get you to the shortest place. But just to show you how bad the optimization is, currently if I ramp this up to, say, 32, then it's not actually that bad. But like if you take it really far out, then it does get a bit mad. Yeah. Exactly. So that's it. Use the Pincho Bar app tonight if you guys want. The link is, I'll just put it back on the link for now.
Seems reliable to me.
Yeah, it is. So the link is just